Hi everyone. So in the last lecture we studied about waveguides and this conclusion we saw. Our wave was traveling inside a waveguides making standing wave pattern in x and y direction and propagation in z direction. It was having EZS, HZS, EXX, HXS, HYS and HEYS. All the components was there, right? Now we will see the mode of a waveguide. What do you mean by mode of waveguide? In a simpler language, it is just the style of propagation. What it is? Style of propagation. So this is what I have written. The mode of waveguides are the possible ways in which EM wave can travel inside the waveguide. So style of propagation is known as modes. Now with specific patterns of electric field and magnetic field. So these patterns we will see later on. The meaning of this line will be clear later on. Specific patterns with electric field and magnetic field. Now the definition, as per the definition, the mode of waveguide are the possible ways in which EM wave can travel inside the waveguide. So this is the style of propagation inside the waveguide. So do you know what do you mean by transverse electromagnetic wave? Yes. If the direction of propagation, is plus z, if the direction of propagation is plus z, then your EZS and HZS would be 0. And EXS, HYS, EYS and HXS, those could be non-zero. But certainly TEM means transverse electromagnetic. That means in the direction of propagation, you cannot have EZS and HZS component. Now using these equations, if I put EZS and HZS equals to 0, then what will happen? This is 0, this is 0, EXS goes to 0. This is 0, EYS goes to 0. This is 0, HXX goes to 0. This is 0, HYS also goes to 0. So what I am saying is that inside a waveguide, if EZS and HZS is 0, then EXS, HYS or EYS or HXS all are going towards 0. So there is no component of electric field, no component of magnetic field. Basically, your complete electric field is going towards 0 and your complete magnetic field is going towards 0. So there is no electric field, there is no magnetic field. So how there will be EM wave? So there is no propagation. So this is the condition of no propagation. No propagation. So inside the waveguide, TEM modes are not possible. In which case? In case of rectangular waveguide. So this I am writing that rectangular waveguide does not support TEM mode. Are you able to understand this point? Inside the waveguide, your EM wave can never be transverse electromagnetic wave. Okay? It could be something else. What it could be? Transverse magnetic mode. Now what do you mean by transverse magnetic mode? What was the meaning of transverse electromagnetic mode? That electric field will be 0 and magnetic field will be 0 in the direction of propagation. Now if I remove this E, what I am getting? TM. So what is the meaning of that? That in the direction of propagation, magnetic field will be 0. What is the direction of propagation? Always we are assuming direction of propagation equals to plus Z. So this is my Z. So in the direction of propagation, magnetic field will be 0. So only which field will be existing? Only EXS would be existing. EZS would be existing. In the direction of propagation, what will be 0? HZS would be 0. But EZS would be non-zero. TEM means transverse electromagnetic wave means in the direction of propagation, electric field and magnetic field is 0. And transverse magnetic means magnetic field is 0. And in which direction? In the direction of propagation. So HZS will be 0 and EZS will be as it is, whatever that we have written. In the X direction, you are having standing waves, both sinusoid and cosinusoid component, and in Y direction, you are having standing wave, both sinusoid and cosinusoid components. So this is known as transverse magnetic mode. Okay. So we will see more about it. So let's talk about this EZ component now. Now we are going to talk about this EZ. So we will find the simplified expression of EZS for transverse magnetic mode. What we need to find? We need to find the simplified expression of EZS. And what we are going to do? We are going to apply the boundary condition. What are the boundary condition? At the boundary of the conducting plate, tangential electric field will always be 0, only perpendicular electric field will be 0. Only perpendicular electric field will be existing. At the boundary of a conducting surface, tangential electric field is always 0. Tangential electric field is always 0, only perpendicular electric field exists. Is that clear to you? So this is what we call as boundary condition. So let's see that boundary condition. We will apply that boundary condition in this expression, and then we will get a simplified expression of EZS for transverse magnetic mode. So in this 5 minutes, we have already seen that transverse electric mode is not possible. What do you mean by transverse magnetic mode? That magnetic field will not be possible in the direction of propagation. So electric field will be there. So EZS component we need to see. HZS is already 0. So now we need to comment on EZS. So what are our boundaries? Our boundaries are this plane, this plane. What is the equation of this plane? X equals to 0. What is the equation of this plane? X equals to A. These basics we have already seen, like a lot of time we have spent. If you are not able to write down the equation of these planes, then you are not studying EMFT at all, right? X equals to A. What is the equation of this plane? This is your XZ plane. That means the equation of this plane is Y equals to 0. And what is the equation of this plane? This plane is Y equals to B. Is there any plane here? No. This is open. Is there any plane here? No, this is open. If you remember the matchbox is gone. But you remember the matchbox, right? So you remember where will be open and where will be the conducting plates. So these are the conducting plates. Now you let me know one thing. At x equals to 0, what is your x equals to 0? This is x equals to 0. What all are your tangential component? At x equals to 0, what all are your tangential component? Y and Z. Perpendicular component for x equals to 0, perpendicular component is Ax cap. And what all are the tangential component? Ay and Az. And you can see here as well, this is the plane. So this is the perpendicular component which is Ax cap. And these are the tangential, Y and Z. So Y and Z component are tangential, right? Y and Z component are tangential. But we are not having Ey expression. So we do not care about Ey expression. We only care about Ez expression. So EZS will be 0. Because at the surface of conductor, tangential component will be 0. So this is a conductor. So at the surface of conductor, the tangential components are EZS and EYS. But we are not caring about EYS component. Certainly EYS will also be 0. But we only need to care about EZS. Okay. We are only caring about EZS. So at x equals to 0, also at x equals to A. At x equals to A as well, this will be the tangential component in Z direction and in Y direction. So at x equals to A as well, your EZS and EYS will be 0. But we are only caring about EZS. Are you getting this point? So what all are the tangential component? Tangential component at x equals to 0 plane and at x equals to A plane, the tangential component are Z and Y. So those are 0 that we can see. Now talking about Y equals to 0. So for Y equals to 0, what is the Y equals to 0 plane? This is your Y equals to 0 plane. This is your Y equals to 0 plane. Let me make it again. So this is your Y equals to 0 plane. If I join this line. So this would be your Y equals to 0 plane. Now let me know one thing. At Y equals to 0, what all are the tangential component? X and Z. At Y equals to 0, X and Z are the tangential component. So at the boundary, at the conducting surface, tangential electric field will be 0. But we only care about EZS. Certainly your EYS will also be 0. Sorry, certainly your EXX will also be 0. Because at Y equals to 0, at this plane, your tangential component are X and Z. So both will be 0. EXS will also be 0. But we do not care about it. But we should write it down. So in a different color of pen, I am writing it down. But we are not caring about it because we don't have the expression of EXS. Sorry, here it was EYS. Because for x equals to 0 and y x equals to A, the tangential component are EZ and EY. And here what are the tangential component? For y equals to 0 and y equals to B. What are the tangential component? EZ and EX. But we don't care about these two. We only care about these two. And same goes for y equals to B. What is your y equals to B? This is your y equals to B. So at y equals to B, you can see this is the tangential component and this is the tangential component. So tangential components are X and Z. But certainly we will only care about z component because we are only having the equation of EZS. So at x equals to 0, now I will put x equals to 0 in this equation. So at x equals to 0, my EZS should be equals to 0. Now if I put x equals to 0 in this equation, what I am going to get? A1 cos kx into 0. So cos 0 is 1. So what I am getting? A1 plus x equals to 0. If I put here, sin 0 is 0. So that is gone. Sin 0 is 0. That is gone. A1 plus 0 is A1 only. A1 plus 0 is A1 only. Okay. Now are you commenting anything about y here? No. What you are putting? Only x equals to 0. So you are not commenting about y. So y will be kept as it is. Y will be kept as it is. And certainly there is nothing about z as well. Right? Now you need this expression to be 0. Because EZS is equals to 0, you need this expression to be 0. You cannot comment about anything about these expression because you are not putting the values of y. So you cannot comment anything about these expression. But you can comment about this expression because you have put the value of x, then you are getting A1. So these values can be non-zero because I don't know the value of y. But certainly A1 has to be 0 because if A1 is 0, then only this expression can go to 0. No, I cannot comment about these expression. But A1 value I am getting after putting the boundary condition here at x equals to 0. So A1 has to be 0. Say yes or no. First conclusion, very important conclusion, that my A1 is coming out to be 0. So that cosine of term will be gone. Right? Now we will put another boundary condition, that is y equals to 0. If I put y equals to 0, so there will be nothing happening with x component. X component will be coming as it is. At y equals to 0, my EZS should be equals to 0. So my x component will be coming as it is, but A1 is already 0. I know that my A1 is already 0. So I am not going to write A1 term. I am only writing A2 cos, not cos, it was sine. A2 sine kxx plus A3 cos kyy. Cos kyy. So I am putting y equals to 0 here. So cos 0 is 1. So it is left with A3 plus A4 sin kyy. So sin 0 is 0. So A4 into 0 is 0 only. So this complete term is gone. So what you are left with? This term. Can you comment anything on x? No. But you can certainly comment on A3, that your A3 has to be 0. So A1 and A3 both are 0. This conclusion we have made. So now what we are left with? A1 is 0. So here we are left with A2 sin kxx, and here we are left with A3 sin kyy. So what we are getting? A2 into A3 sin kxx into sin kyy. And what is A2 into A3? It is some constant. A2 into A3 is some constant. So EZS I am writing as E naught sin kxx into sin kyy. So this I am writing as Ez. This is not the complete expression, but till now this expression we have got after applying two boundary conditions. Now we are having another boundary condition. What is that? At x equals to a, again your EZS should be 0. At x equals to a, again your EZS should be 0. So I will put x equals to a in this expression because we have reduced down the expression. Now if I put x equals to a, so E naught kx into a into, I am not putting anything about y. So certainly I cannot comment about anything. Certainly I cannot comment about this. Now E naught is an amplitude, so that cannot be 0. So which guy has to be 0 now? This guy has to be 0. So from here what you are getting? That your sin kx into a has to be 0. Sin kx into a has to be 0. And if sin kx into a has to be 0, that means kx a has to be pi, because if you remember the graph of sine, so at pi, 2 pi, 3 pi, so at all these points your sine graph is 0. So instead of pi, what I'm gonna write down m pi. So what I'm getting, kx is equals to m pi by a. So kx value I am getting as m pi by a. Similarly, at y equals to b, you will put this as equals to 0. So if you put this as equals to 0, what you will get? You are putting the value of y. So you cannot comment about anything about x. So x will be remaining as it is. Then this term will have to go to 0. And what you are putting, y equals to b. So ky into b has to be equals to n pi. If you are giving m name here, then here you will give n name. So ky into b has to be equals to n pi. So from here, your ky is coming out to be n pi by b. So what you have done? E naught is a constant, sine kx value you have got and ky value you have got. So this derivation is not important, but this process is important. In any of the question, they can ask you to apply the boundary conditions. So this process is important. Now, which equation I have got? E naught into sine m pi by a into x into sine n pi by b into y. Because I will put the ky value here and I will put the kx value here. Then I will get the expression of EZS. So when I wrote down this expression, instead of that expression, I could have written down this expression directly. But I did not write it because this process is important. This is the step of derivation only. But this step of derivation is important. It can be asked in the examination in any of the questions. So you should know how to apply these boundary condition in waveguide. So what we got to know that A3 is gone, A1 is gone, then this is the expression. And now in this expression, kx is equals to m pi by a and ky is equals to n pi by b. So what is the EZX expression you are getting? E naught sine m pi by a into x sine n pi by b into y. So this is your EZS expression and you need to remember it. How will you remember in a longer run? Isha is sweet, right? Isha is sweet. E S. So if E is there, then sinusoid component are coming. And what is Himanshu? Himanshu is careless. So H and C. So when you write down the expression of HZS in the next mode, here HZS is 0. In transverse magnetic mode, HZS is 0. But there will be one more mode where HZS will not be equal to 0. So at that time, your cos component will come. So that's why I asked you to remember these two terms. Isha is sweet, that means E will be related with S. So both terms are sine. So here can I write down one thing? Roughly I am writing it down, okay? Roughly I am writing it down that it is a function of sin x and sin y. Just a rough estimation I am telling that both sign are there. E naught sin m pi by a into sin n pi by b. One more thing you will remember that m is always associated with x and n is always associated with y. You do not interchange it, okay? Never interchange it. M is associated with x and n is associated with y. So do not interchange it. Is that clear to you? So this thing also you will keep in mind. So what is the EZX expression we are getting for which mode? Transverse magnetic mode. The EZS expression is E naught sin m pi by a into x into sin n pi by b into y. So both components are sinusoid. Both electric field components are sinusoid. Both are coming sinusoid. What do you understand from there? What does this represent? Standing wave in x direction. Wait a second. This expression is not complete. Really sorry for the mistake. This is a big blunder. What is the blunder? I forgot to write down e to the power minus j beta z. Here also I forgot to write down. Really sorry. Here also I forgot to write down e to the power minus j gamma gz. This expression I forgot. Wave is propagating in z direction. No? So how I can forget this expression? So this expression will also come. So what does this represent? Standing wave in x direction. What does this represent? Standing wave in y direction. And what does this represent? Direction of wave propagation, or I should have written traveling wave in z direction, traveling wave in z direction. Now you let me know one thing. If this is the cross section of waveguide, what I am drawing, I am drawing this surface. This is the cross section of waveguide. I am drawing this surface. Okay. This was your 0, this was your A, this was your B. Now you know one thing. Here at the boundary, because here there is conducting plate, here also there is conducting plate, on the upper side as well there is a conducting plate. So when the wave comes like this, if any wave is coming like this, it will be striking to a conductor, then it will be making a standing wave pattern. So at this boundary, what you will get? Standing wave. And that standing wave you will get, and your electric field will be minimum there. You will get minima. Here at this boundary you will get minima, right? You will not get maxima. What you will get? Electric field minima you will get. And if you are getting minima, then the expression will be sinusoid or cosinusoid. If the expression was cosinusoid, then here you should have got maxima. No? But what you are getting? Minima you are getting. So expression has to be sinusoid. This is just the intuition behind it, that why sinusoid is coming. Because at the boundary, at the conducting surface, if the wave is coming, you will make minima here. No, in x direction you are getting minima. First minima, then maxima. So first minima you are getting here, and at x equals to 0, if you are getting minima. But if I had put, let us say, if this was the expression, if expression was m pi by a cos m pi by a into x. So at x equals to 0, what will be the value of cos? That would be 1. So that would represent the maxima. At x equals to 0, you are getting maxima. But actually you are getting, at x equals to 0, you are getting electric field minima. So if you are getting minima, then it has to be sinusoid. Is that clear to you? So that's why sinusoid expression is coming. In that manner you can remember. Here you need to use your brain. But if you remember the line, ECE is sweet, then you don't need to use your brain. You can directly write down the expression. But you will always understand that electric field minima is made. Always minima is made. And if minima is made, then sinusoid component will come or cosinusoid. If at x equals to 0 you need minima, that means you need the value to be 0. If I need value to be 0 at x equals to 0, then certainly sinusoid has to come. So E naught sin kx is m pi by a into x into sin ky is n pi by b into y, and direction of propagation, that is e to the power minus gamma g z. So this is how you can write down Ezx expression. Just one thing is that it is a function of sin x and sin y. Both are sin x and sin y. So in any rough place you can write down this thing, that you will get minima. So that's why we are getting sin component. Okay. Now what are these m and n? Let's discuss about these m and n. So we will discuss it, but can you draw the graph of sin x? Yes. What will be this point? Pi. This thing we have already seen in basics. When we were studying EM wave, this thing we have already seen. So pi, 2 pi, 3 pi, 4 pi. If I draw the graph of sin 2x, then what will happen? All these will be divided by 2. So this point will be pi by 2, this point will be pi, and this point will be 3 pi by 2. And if I am making the graph of sin m pi by a into x, then all the points will be divided by m pi by a, right? All the points will be divided by m pi by a. So what this point will become? A by m. What about the next point? Next point will become 2a by m. What about the next point? 3 pi divided by m pi by a. So next point will become 3a by m. And this point will become 4a by m. Right? Is that clear to you? So this will be the graph of sin m pi by a into x. Now if I say my m value is 1, and I am making my cross section here, cross section of waveguide. Cross section of waveguide says that this is your x equals to 0, this is your x equals to a. So in the waveguide, what you will get? You will get the standing wave pattern like this, right? In this manner you will get the standing wave pattern. But if I have put m equals to 1, if my m is 1, then only this much lobe will come, no? Because if m is 1, then this will be a, this will be 2a, this will be 3a, and this will be 4a. If m is 1, then this will become a, this will become 2a, this will become 3a, and this will become 4a, right? And how much width I am having? I am having the width of A only. Now in this width, how much half cycle will come? I am talking about half cycle. I am not talking about full cycle. This is one half cycle. This is another half cycle. This is another half cycle. And this is another half cycle. So how many half cycles will come in this 0 to A? If M value is 1. If M value is 1, then only one half cycle would come. Right? If M value is 1, then only one half cycle would come. If M value is 2, then what will happen? This will become A by 2. This will become 2A by 2. This will become 3A by 2 and this will become 4A by 2. What is 2A by 2? 2A by 2 is A only. If M value is 2, then from 0 to A, what is this? This is A only. So from 0 to A, two half cycles are coming. Right? So if your M value is 2, then two half cycles would come. Let's make it better and with different color of pen. If M value is 2, then two half cycles would come. So this we have made for M equals to 0. Sorry, not M equals to 0, sorry, M equals to 1. And this we have made for M equals to 2. So if M value was 1, then one half cycle was coming. If M value was 2, then two half cycle was coming. And where the half cycles are coming? In X direction. This is the direction of X. So in X direction, two half cycles are coming for M equals to 2. For M equals to 1, one half cycle is coming. If I put M equals to 3, then what will happen? If I put M equals to 3, then what will happen? If I put M equals to 3, this will be A by 3, this will be 2A by 3, this will be 3A by 3. That will be A only. So till A, from 0 to A, one half cycle, two half cycle and three half cycle. So three half cycle will come. If I put M equals to 3, then three half cycle will come in this manner. In this manner, three half cycle will come. So we will not make it, otherwise the diagram will be complex. But you are understanding the point, right? Here three half cycle would have come. So what the value of M is representing? If M is 1, then number of half cycle in X direction is 1. If M was 2, then the number of half cycle in X direction was 2. And if M is 3, the number of half cycle in X direction is 3. So what does M represent? M represents the number of half cycle in X direction. Similarly, what N will represent? N will represent the number of half cycle in Y direction. Is that clear to you? Is that explanation clear? Right? Although these are standing waves, so when we make standing wave, how do we make it? Like this we make it. Here this negative will be replaced with positive. If we make the standing wave, negative is replaced with positive. If you remember the lecture of standing wave, there I told you that how do you represent a standing wave? Standing wave means across two fixed node, up down, up down. So this node will be going up down, up down, up down. This node will be going up down, up down, up down across these two fixed nodes. So usually we show the amplitude. So here if I need to show the standing wave, then I will show it like this. Okay, but here I am showing with the amplitude, here I am showing with the negative sign. So this is just to show. This will not be asked in the examination, but I am just telling that what is the definition of M, what M is representing. So if M, this was the graph of sin M pi by A. So if M was 1, then from 0 to A only one lobe was there. If M was 2, then from 0 to A 2 lobe was there. If M was 3, then 0 to A 3 lobes were there. So M represents the number of half cycle in X direction and N represents the number of half cycle in Y direction. Is that clear to you? Is the definition of M and N that is clear? The expression of EZS is also clear. What was the expression of EZS? Here I am writing down the expression of EZS. The expression of EZS was standing wave pattern having minima in X direction and standing wave pattern in Y direction, e to the power minus gamma g z. So this was your EZS expression. Now we are going to write down EXS, EYS, EHXS and HYS expression. So these expression we are going to write down. Do we need to mug it up? No. What we remember? We remember this formula. What is our EXS? So firstly, what I need to write? Gamma g upon h square. Then del by del x. I saw x here. Del by del x. Then E I saw EZS. Here Isha's x will be negative because Isha is a sweet girl. So Isha's x will be negative. So minus j omega mu upon h square del by del y HZS. So trick I have already told how to write down, but here you do not need to care about this expression. Why is that so? Because this will be going towards 0. So I do not need to care about this expression. This will be going towards 0. So this will be my EXS. In a rough node, in a rough manner, you can write down here. Okay, let me write it down only for you. So why this expression we are not writing? Because I know that my HZS is 0. So this complete term is going towards 0. So this expression we do not care. So this is the final expression we will get, minus gamma g upon h square del by del x EZS. Okay. Similarly, here what expression you will get? Minus gamma g upon h square UCY del by del y EZS. Similarly, HXS. So here what happens? Minus gamma g upon h square, then del by del x. Here what comes? HZS comes, right? And then what do we write? Himanshu's x will be positive. So j omega epsilon upon h square del by del y EZS. Just opposite of this, x, y, hz, ez. So this is what you write down. But here HZS will be going towards 0. So what you will be left with? J omega epsilon upon h square del by del y EZS. Similarly, here, if here there was positive sign, so now here will be negative sign. So j omega epsilon upon h square del by del x, because first del by del y would come. So here del by del x would come, and this would be EZS. So you should have the habit of writing down these expressions. So this expression, this expression, this expression, and this expression. Do you have the value of EZS? Yes. Gamma g upon h square, that will remain there as it is. Gamma g upon h square will remain there as it is. J omega epsilon upon h square will remain there as it is. You have this value. You just need to differentiate. First expression I am telling, if I differentiate this with respect to x, what I am going to get? Minus gamma g upon h square will remain there as it is. Okay. Then I am differentiating with respect to x. So E naught is a constant, E naught is there as it is. If I differentiate with respect to x, then m pi by a is a constant that will come out m pi by a. Then this sign will convert to cos, and this will remain there as constant only. Why constant? Why it will be constant? Because this is y. You are differentiating with respect to x. So this will be constant and this will also be constant. So these two term will come as it is. So this is something we will be getting ahead, minus gamma g upon h square, minus gamma g upon h square, m pi by a into E naught, and then this expression. Sine will convert into cos, right? So certainly you do not need to mug up these expressions. Certainly no need to mug up these expressions. What I am saying, you don't need to remember these expressions. But let's make something conclusive from here. What I'm going to do, I'm going to make something conclusive from here. Because questions are asked on this particular concept. That's why we are spending a lot of time. Usually you would see that not a lot of people spend time on these derivations, but questions are asked. I will show you the questions has been asked on this particular topic. That's why I am spending time here. Okay, so EXX expression we have write down. How we are writing down this expression, that you know, that HZS is equals to 0, and this expression also you know how to write down. So very easily you will be able to write down. If you know the EZS expression, then if any day you need to write down these expressions, then you can write down simply by differentiating. But what you are doing after differentiating, you will get these expressions. What do you see here? Your EXS is a function of cos and sine. It is a function of cos x and sine y. This is EYS is a function of sin x cos y. This is a function of sin x cos y, and this is a function of cos x sin y. Certainly there is m pi by a, n pi by b, certainly there is this thing, and certainly these terms are also there, but something conclusive you can see here, that no one is cos or sin sin, cos sin, sin cos, cos sin. None is cos, none is sin sin. Where you are getting sin sin? Here you are getting sin sin. So if any expression is given in front of you, let us say I randomly give this expression, will you be able to understand that whether it is EZS or EYS or EXX? This expression I give you in front of you, I will put this expression, Will you be able to tell me that it is EYS or EXS or EXS, EYS, EZS, or it could be HXS as well, it could be HYS as well. So will you be able to tell me? No. If you don't know the concept, then you will not be able to tell me. But what you will see, that sir, sign is there. So certainly it cannot be any of these. Are you getting this point? When do you get sign? In EZS. So this expression has to be EZS. Are you getting this point? And if there is sine cos or cos sine, sine cos or cos sine, then certainly it cannot be EZS, it could be one of them. So can you just remember one thing, that your EXS is a function of cos x and sin y. Can you remember this thing? Your EXS is a function of cos x and sin y. Because if you remember EXS, if your field is in x direction, if your electric field is in x direction, then where will be your magnetic field? In y direction. So EX and HY are brothers. EX and HY are brother. So if this is cos x sin y, then certainly it is same as EXS. So one, if you remember cos x sin y, then certainly EY will be opposite of that. EY will be opposite of that. If this is cos x sin y, then certainly you will be able to write down about EY, that will be sin x cos y. And if you remember EY, then if your field is in y direction, if your electric field is in y direction, where will be your magnetic field? That will be in x direction. So EY and HX both are brothers. So sin x cos y, sin x cos y. So here what I am asking you to keep in mind, this expression I am asking you to keep in mind. These expression you can derive any day, right? These expression you can derive any day, because in the last lecture we have studied it, and these expression you can derive any day. But the thing is that my EZS is a function of sin. EZS is a function of sin, that I remember because Isha is sweet. So EZS is a function of sin. If I talk about EXS, so that is a function of cos x sin y. Here it is sin x sin y, that is cos x sin y. Just you need to remember this thing, EXS is cos x sin y. If EX is cos x sin y, then what would be your HY? Because EX and HY are brother, because if electric field is in x direction, then magnetic field will be in y direction. So EX and HY are brother, so cos x sin y will be there in HY as well. Now if in EX cos x and sin y is there, that means in EY you will have sin x cos y, and EY and HX are brothers, so certainly both will follow the same rule. This will be used in some of the questions. In some of the questions this will be used. A very good level of questions can be framed from this particular concept. And if you don't want to remember this thing, okay, let's just say you don't want to remember this thing, you forget this thing, that it is a function of cos or sin, you forget this thing, then how can you derive it in the examination? What you will get to know, that sir, this is your transverse electric mode, this is my transverse magnetic mode. Okay, in transverse magnetic mode I am having EZS equals to non-zero. So if I write down EXS expression, what that would be? Minus gamma G upon H square del by del X EZS. Okay, right? This expression will be there, and HZS component will be 0. So that I don't care. So this expression I will be getting. Now forget about this amplitude. Let's talk about this del by del X EZS. So what will happen? EZS will be differentiated with respect to X. And one thing I will certainly remember, that Isha is sweet. So E is a function of sin X and sin Y. So if I differentiate with respect to X, then this sin X will be converted into cos X, but I am differentiating with respect to X, so this sin Y will remain there as it is. So EY is a function of cos X and sin Y. Sorry, EX is a function of cos X and sin Y. So within 10 to 15 seconds you can derive in the examination as well. If you get confused or if you forget, what is the step? Did you understand what is the step? You will write down, sir, EXS, and you go to know, anyhow you go to know that it is transverse magnetic mode. If it is transverse magnetic mode, that means certainly EZS is equals to non-zero. If it is non-zero, then what will be my EXS? That expression I know, minus gamma G upon S square del by del X EZS. Now EZ I know because Isha is sweet, so sin X, sin Y. So if I differentiate them, so I am differentiating with respect to X. So this will be cos X, sin Y. So function will be cos X, sin Y. So my EX is the function of cos X, sin Y. Then you will be able to remember EX, HY. then EY HX, just the opposite. So if it is cos x sin y, that would be sin x cos y. So just opposite would be there. Cos x sin y, sin x cos y. Just opposite would be there. So in that manner you can derive. If you don't want to remember this thing, if you don't want to remember this, then you can derive in the examination itself. Is that clear to you? I will prefer deriving it. At least I will prefer deriving EX. And when we study another mode, that another mode will be, here what we are studying, transverse magnetic mode we are studying. Next mode would be transverse electric. So there also we will derive this expression, and the good news is there also EXS will be function of cos x sin y, EYS will be function of sin x cos y, and HXS is a function of sin x cos y, and HYS is a function of cos x sin y. So there also we will get the same functions. Oh, certainly these expressions will be different. These expressions will be different, but the function, the type of function would be same. And why I am spending so much time here? Because questions will be based on this. Okay, questions will be based on this, and that will help us a lot in solving the problems. So that we will see later on in this video only. We will see in the end, we will see those kind of questions, that they will give a particular expression and then they will ask you the mode, and then they will ask you that whether it is what kind of mode was there and how did you determine the mode. So these kind of questions can be asked in the examination, and usually when they frame a good question from a waveguide, then they ask these kind of problems only. So are you able to relate with the derivation and all these things, that why we are spending so much time here? Okay, now let's just say in the examination this kind of expression is given in front of you. Okay, this kind of expression is given in front of you, and certainly this is also given. We will discuss about this point later on. Okay, let's forget this point, because it would be good if I compare TE and TM. Here I am not going to compare, because here I can only talk about TM mode. We haven't studied TE mode. When we study about TE mode, then I will discuss this point which I was talking here. Okay, so that we will discuss later on. So forget about this point. As of now, till in this lecture, what we have studied, we studied how to apply the boundary condition, and using the boundary condition we are getting sin. Okay, in EZS component. Then for finding EX, EY, HX and HY, what we need to do? Why I am putting S? Because the phasor form I am writing. No? These are the phasor form. Here there is no j omega t. If I need to write down that time harmonic vector field, then I will introduce e to the power j omega t. I will introduce e to the power j omega t. Here I am writing on the phasor form, that's why I am writing SSS there. So EX, EY, HX and HY, these expression we get using these formulas. So these formula we know how to write down. We don't need to mug up these expressions. If we need to keep in mind one thing, that thing could be our EX is a function of cos x sin y. EX is a function of cos x sin y. Is that clear to you? Okay. So this we have seen about transverse electric. Now more things we will see. More things. So now we will see a very important point: existing, non-existing and lowest order mode in transverse magnetic mode. Okay, so what is M? Number of half cycle in x direction, number of half cycle in y direction. So if M and N both are 0, then what will be the value of EX, EY, HX, HY and EZ? Certainly first thing is that our HZS is already 0, because this is a transverse magnetic mode. So HZS is already 0. Now let's talk about EXS. If M is 0 and N is 0, so if M is 0, EXS is 0, because if you put 0 here, this will be completely 0. What about EYS? If N is 0, this will be 0. If N is 0, this will also be 0. If M is 0, this will be 0. So all these are 0. Here if M is 0, this will be 0. If N is 0, then also it is 0. So all are coming 0. If M and N both are 0, that means EXS, EYS, HXS and HYS all are coming 0. So that means it is non-existing mode. Non-existing mode. So never ever your M and N value can be 0 in case of transverse magnetic. And how do you represent a mode? You represent a mode like this: TEMN. TEMN. First you write down the value of M, then you write down the value of N. And M is associated with X and N is associated with Y. So this is how you write down a mode: TEMN. So if this is written, then what do you understand? That the mode is transverse magnetic and the value of M is M and the value of N is 1. If I write down TE22, That means the mode is transverse magnetic, the value of M is 2 and the value of N is 2. So what did we get to know? That TM00 can never be written. Why is that so? Because 00 means M is equals to 0 and N is equals to 0. And if M and N is 0, then all these are 0. And if everything is 0, that means wave is not even propagating. So this is non-existing mode. Are you getting this point? So this is known as non-existing mode. So TM00 is never possible, right? TM00 is never possible. So here I am writing, if both are 00, that means TM00. So this is never possible. Let's talk about this thing. What this would be? Here M is 0, but N is some non-zero value. It could be anything. It could be 1, 2, 3, 4, it could be anything. That means number of half cycle in X direction is 0, but the number of half cycle in Y direction could be anything. It could be 1, 2, 3, 4, anything. So let's write down the values. Certainly HZS will be equals to 0. Let's talk about EXS. So M is 0 and N is equals to non-zero. If M is 0, then this will be 0, right? If M is 0, N is not 0, then hold. M is 0, then what is sine 0? Sine 0 is 0, and this quantity is also 0. Are you getting this point? If M was 0, then certainly this quantity is 0, because here you will see 0. So 0 into pi, anything, the complete quantity will be 0, right? What about this? If M is 0, then sine 0 will be 0 only. So this is also going to 0. Here, what about this? If M is 0, then sine 0 is 0 only. So this is also going towards 0. And if M is 0, then this is 0. So this is also going towards 0. And here if you put M equals to 0, then sine 0 is also going towards 0. So again, all these are coming towards 0. Are you getting this point? I am just putting the value of M and N here. M is some finite value, so I cannot comment about N. But M is 0. If I put M equals to 0, this is going towards 0. If I put M equals to 0, this is going towards 0. If I put M equals to 0, this is going towards 0. And if I put M equals to 0, this is going towards 0. And if I put M equals to 0, this is going towards 0. So all these are 0. All these are 0. EXS, EYS, HXS and HYS. All these are again coming towards 0. So again it is non-existing mode. What about this? If M is non-zero but N is 0, that means M is non-zero but N is 0. N is 0. If you put N equals to 0 here, this will be 0. N equals to 0, if you put sine 0 will be 0. This will be 0. If you put N equals to 0 here, this will be 0. If you put N equals to 0 here, this will be 0. And if you put N equals to 0 here, this will be 0. If you put N equals to 0 here, this will be 0. All these are again coming out to be 0. You need to put N equals to 0, 0, 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 and N equals to 0, 0. I am not putting the value of M. M is some finite value that I don't know. So again, what is happening here is that HZS was already 0, because what we are studying, transverse magnetic. But here, EXS, EYS, HXS and HYS, all are coming towards 0. And what do you understand by this? Non-existing mode. But if M and N are finite, sorry, if M and N are non-zero value, that this will be some non-zero value, this is some non-zero value, this is also some non-zero value, then they will be existing, right? If M and N both are some non-zero value, then this is your existing mode. So either of M or N cannot be 0. Both simultaneously cannot be 0, and one of them can also not be 0. So either of M or N cannot be 0. So what you can never see? TE00, TM00 you can never see, TM0N you can never see, and TMM0 you can never see. So these things you can never see. These modes are non-existing mode. And certainly this is existing mode. Okay. And how will you remember? So what are the non-existing mode? TM00, TM0N and TMM0. So in the subscript you can never have 0. So TM sounds as team, no? Team. TM sounds as team. So you can never put your team towards 0. You can never put your team towards 0. TM sounds as team. So you can never put your team towards 0. So you can never have 0 here. one of the 0 also you cannot have, M0 also you cannot have, or 00 also you cannot have. So this is how you can remember. So how will you remember that TM sounds as team? TM sounds as team, and we can never put our team equals to 0. So TM sounds as team. So this is the way you can remember. TM sounds as team. So we can never put our team equals to 0. So what is the lowest order mode? Lowest order mode. What do I mean by lowest order mode? That means what is the least value I can put? What is the least value of M I can put? 1. And what is the least value of N I can put? 1. What I mean to say is that M equals to 1 and N equals to 1. These are the least value possible. Right? So this is what we mean. Lowest order mode is TM11. Let's solve this question. Very easy question. Which are the possible modes? TM12 possible. TM02 not possible. Why is that so? Because you cannot put your team equals to 0. TM10 not possible. TM21 possible. That's it. Okay. Do we have anything else? No. Then we need to study transverse electric mode. So let's revise about our transverse magnetic mode. We started from here. We understood the meaning of transverse magnetic mode. That our magnetic field will be 0 in the direction of propagation. Okay. But EZS will be equals to non-zero. Certainly our EX, EY, HX and HY all are existing. So what I can make here is that certainly our if this is my X, so EX, EY and all these are existing. If this is my X, this is my Y. So EX also exists, HY, sorry, this is HX only, HX also exists, EY also exists and HY also exists. So these exist, but HZS is not existing. Okay, all these are equals to non-zero. But certainly my HZS is equals to 0. So this is the meaning. Then we applied the boundary condition. We know how to apply the boundary conditions now. At x equals to 0, at x equals to b, there is conducting plate. So what you will see, the tangential component of electric field will be 0. So EZS has to be 0. So those conditions we applied, and then we got to know that our EZS component is having both sinusoid. And intuitively also we understood it, because at boundary plate you need to have minimas. And if you need to have minima, then certainly sine function would be there. Cos function cannot be there. So that's why we are getting standing wave pattern in x direction having minima at x equals to 0 and x equals to a. Standing wave pattern in y direction having minima at x equals to 0 and x equals to b. And direction of propagation is e to the power minus gamma g z. The other thing we got to know is that it is a function of both sine. So this we need to remember, and how we will remember that Isha is sweet. So in that manner we will remember. And M is always associated with X and N is always associated with Y. What is the meaning of M and N? Number of half cycle it represents. Number of half cycle in X direction is M, number of half cycle in Y direction is N. Okay, because if the M value was 1, then half cycle we were getting 1 only. If M value was 2, then half cycle we were getting 2. In that manner we can understand. Then we find out EX, EY, HX and HY expressions. So that expression we can find out. Certainly what we need to do, we need to put HZS equals to 0. Then these expression we will get. Which expressions? I can highlight this expression. This expression is equals to this, then this and this. Certainly you don't need to mug it up. You can always write it down. Then when we do the when we do the differentiation, this is what we get. Interesting thing we notice is that EX and HY are brother. Basically their magnitude would be different, but certainly both will be function of cos sine. And EY and HX are brothers, both are function of sin x cos y. So if you can keep in mind that EX is a function of cos sine, then you can write down HY, then you can write down EY as well and HX as well. In that manner you will be able to write down. So that thing we saw. And then what did we see? What are the possible modes? Existing mode, non-existing mode we saw, and then lowest order mode we saw. So certainly TM 0M, TM 00, 0N and M0 can never be existing. The minimum possible mode is TM11. Why they cannot exist? Because all these are going towards 0. So they cannot exist. Okay. Lowest order mode is TM11, and then we saw a very simple numerical. Okay. Now we need to study about transverse electric mode. So all the things you can do on your own here, because we have already studied about transverse magnetic mode. But here the boundary condition will be a bit different. It will be a bit typical, I would say, or it will be interesting. So that boundary condition will be interesting here. So that boundary condition we will apply, then we will see the expressions. After that we will see these expressions, then we will see what all are the functions we are getting. And in the same manner we will find out existing, non-existing, lowest order mode, and then we will see this numerical, and then we will write down the summary. So certainly now I will be taking a break. You can also take a break, and after that we will start studying about transverse electric mode. Okay, let's start studying about transverse electric mode. So in transverse electric mode, what do you feel, what will happen? The direction of propagation we are always taking as positive z. So what is transfer now? Electric field is transverse. That means electric field will be EZS will be 0 in the direction of propagation, but HZS will be equals to non-zero. So EZS will be 0 and HZS will be as it is what we have written. So if this is my Z, this is my X, this is my Y. X cross Y is giving me Z. So yeah, then here HZS will be existing. HZS will be existing. Now we need to study this HZS expression. We need to apply boundary conditions and we need to reduce this particular expression. Okay. So that we need to reduce. So how we will apply the boundary conditions, because applying boundary condition is important, because that can be asked in your examination. So let's start applying the boundary conditions. But before that, before starting it, let's write down the equation of EX, EY, HX and HY for TE mode. For which mode? For TE mode. So what is the actual expression of EXS? That is minus gamma G upon H square del by del X EZS. But here EZS is equals to 0. EZS is equals to 0. So here EZS is equals to 0, then this term will be completely gone. Now what will happen? Now J omega mu term will come. So Isha is a sweet girl, so Isha's X will be negative. So minus J omega mu upon H square del by del Y HZS, that will come, right? Same goes here, J omega mu upon H square del by del X HZS will come here. What about this? Here, what will be the first term? Minus gamma G upon H square del by del X HZS. So that term will be non-zero, next term will be 0 there, because in the next term EZS would be coming, so that would be 0. And what about this one? Minus gamma G upon H square del by del Y HZS. So these are the expressions. Now, do I know any boundary condition for magnetic field? No, I did not teach you any boundary condition for magnetic field. I just teach you one thing, that here electric field will always be perpendicular. Tangential component of electric field is 0. That I know. So at x equals to 0, what all are my tangential component? EZS is always 0. Here EZS is always 0. So forget about EZS. EYS will also be 0, no? At both of these boundaries. This we have already seen. At x equals to 0 and at x equals to a. Here EYS is also a component. So if EYS is 0, but I need to study HZS expression. I need to study about HZS expression, but I am getting my EYS is 0. So if my EYS is 0, then look at these expressions. If EYS is 0, then can I write down that my del HZS divided by del X is 0. If this is 0, then this will also be 0, because this is some quantity that cannot be equal to 0. So this has to be 0. So at x equals to 0 and at x equals to a, what you are getting? This guy is equals to 0. This is what you are getting. Similarly here as well, at y equals to 0 and y equals to 0, b, what all are the tangential component? EZS and EXS. So if your EXS is 0, if your EXS is 0, then what will happen? Del HZS divided by del Y. Del HZS divided by del Y will be equals to 0. So now you can apply the boundary condition. So did you understand how we are going to apply the boundary condition? We need to differentiate this with respect to x and with respect to y, and then we can apply the boundary condition at x equals to 0, at x equals to b, a, y equals to 0 and y equals to b. So whose help we took? We took the help of this guy that we need to write down for TE mode. These will be our EX, EY, HX and HYS expression. We know that EZS and EYS is 0. If EYS is 0, then this differentiation is 0, and then this differentiation is 0. Now if those differentiation are 0, then I will differentiate this HZS and I will put that equals to 0 at these boundary condition. So first I need to differentiate it with respect to x, and then I need to differentiate it with respect to y. So differentiation you can do. What will be the differentiation with respect to x? So differentiation with respect to x will be b1 kx minus sin kxx plus b2 kx cos kxx, because differentiation of sin is cos, differentiation of cos is minus sin, and then this will remain there as it is. So this is your del hz by del x. And what about del hz by del y? So this will remain there as it is, b3 ky minus sin ky y plus b4 ky cos ky y e to the power minus gamma z will be there, remaining there as it is. So this will be the differentiation. Very simple differentiation, very simple mathematics we need to do. Now what we need to do, that at x equals to 0 and x equals to a, and at y equals to 0 and y equals to b, we are having these conditions. So first I am going to apply at x equals to 0, I am having this equals to 0. So at x equals to 0, this is equals to 0. So if I put x equals to 0 in this expression, what will happen? Sin 0 will be 0. So this b1 will be gone. If I put x equals to 0 here, what I will be left with? b2 kx. Then this y expression will be there as it is, e to the power minus gamma z will be there as it is. And now this has to be equals to 0. This complete expression has to be equals to 0. You cannot comment anything about y. You cannot comment about z. Certainly kx is non-zero. Why kx is non-zero? Because you know one thing, that kx, ky and kz, for waveguide all these will be non-zero. So certainly my kx is non-zero. So which guy has to be 0? b2 has to be 0. So here what you are getting, my b2 is 0. So did you understand how we are applying our boundary conditions? Very important. Like, I wouldn't say very important, but what I feel is that some questions can be asked from these boundary conditions. In any question they can include boundary condition that you need to solve this kind of thing. They can give you any expression and then they can ask you to solve the boundary conditions. So that's why we are solving it. Now at y equals to 0, at y equals to 0, HZS, sorry, del HZS divided by del y is equals to 0. At y equals to 0, del HZS divided by del y is equals to 0. So now if I put y equals to 0, I need to put this equals to 0. So here x expression will be there as it is. What I am putting? Y equals to 0. So if you put y equals to 0 here, sin 0 is 0. So this term will be gone. What will be left? b4 ky will be left, and cos 0 is 1. And then e to the power minus gamma g z. Certainly this cannot be equals to 0, ky cannot be equals to 0, this cannot be equals to 0. Then b4 has to be 0. So from here what you are getting? b4 is 0. What is 0? b4 is 0. So now what you are getting? What is your hz now? So in hz, this sin ky term is gone, and what all things are 0? b2 and b4 is 0. So that means this term is gone and this term is gone. So what you are left with? b1 cos kxx, b3 cos kyy. So what I can do? b1 b3, and this b1 into b3 can be some constant, right? So h0 I can write down. Cos kx x we are getting, and cos ky y we are getting. So this is the hz expression we have reduced. In two boundary condition we have reduced the expression in this manner. Video chal raha na yaar? Yeah, video chal raha hai. Yeah, so what I was saying, so this is how we have reduced. Now we have another boundary condition at x equals to a and at y equals to b. So that boundary condition also we can apply. So at x equals to a, I need to put this differentiation equals to 0. Del hz divided by del x. So can you do the differentiation? Yes, certainly I can do the differentiation. With respect to x, I need to do the differentiation. So what I will be getting? h0 kx sin kxx, negative sign will also be there because differentiation of cos is minus sign, into cos ky y, and that is equals to 0. I did the differentiation with respect to x, so I cannot comment about anything here. I cannot comment about, I can comment about these things. This cannot be 0, this cannot be 0. So what has to be 0? This has to be 0. And if this has to be 0, that means, and where you are putting the value? You are putting the value of x equals to a. Which value you are putting? You are putting the value of x equals to a here. So I am putting the value of x equals to a. So this guy has to be equals to m pi. So kx a is equals to m pi. So kx value you are getting same. m pi by a. So kx value you are getting same. Okay. So from here, this conclusion you were making, and then kx is equals to m pi by a. Similarly, what will be your ky? So ky also you can find out. What you need to do, again you need to do the differentiation only. But here, this x term will be remaining there as it is. But if I do the differentiation with respect to y, then minus sign would come. Sorry, this was cos, not sine. This was cos. And then minus sign would come, and here it will become sine k by y is equals to 0. Instead of y, I am putting b. So what is my ky is becoming? Ky is becoming n pi by b. And if I put the kx and ky value, what I am getting? H naught cos m pi by a into x. Here again I am doing that same mistake. Which is that mistake? I always forget minus gamma g z. Here I am not forgetting. Here also minus gamma g z would be there, but forget about that. Minus gamma g z will also be here, also that will be there, but forget about that. From here we are getting the value of ky, that is n pi by b, and this expression we will be getting. So here what do you understand? That this is a function of cos x and cos y. And how will you remember? Himanshu is careless. If Himanshu is careless, so cos and cos. Isha is sweet, so in terms of Ez as sine and sine was coming, and certainly here there would be E naught. So this is how you can keep in mind, right? Now, intuitively, if I need to see what does this represent? Standing wave pattern in x. What does this represent? Standing wave in y. And what does this represent? Traveling wave in z. Now add the boundary. If I make this cross section, add the boundary. If the wave comes, what will happen? Reflected back and standing wave pattern will be made. So add the boundary at x equals to 0. What you are going to get? Electric minima and magnetic maxima. Magnetic maxima. So at x equals to 0, you need maxima. If you use sine, then at x equals to 0, sine 0 will be equals to 0 only. So that you don't want. If you use cos, so at x equals to 0, cos 0 will be 1. So that's why cos you are getting. Similarly in x direction, similarly in y direction as well, at y equals to 0 and at y equals to b, you will get maxima only. So that's the reason. Are you getting this point? Intuitively also you can directly say that here cos will come. Why cos will come? Because at the boundary surface at x equals to 0 and x equals to a and y equals to 0 and y equals to b, you will have magnetic maxima and electric minima. So in case of electric field, you are getting sine component, and here you are getting cos component. So that is the intuition. But derivation is also important, because they can give you anything random and they can ask you to apply boundary conditions, or they can simply ask you this thing in the option. What they can put? For a rectangular waveguide at x equals to 0, del hz divided by del x is equals to 0 or not. They can simply ask whether this statement is correct or not. So these kind of questions they can also ask. So from these boundary conditions, I feel that someday in some examination some question can be made. That's why we are doing so. Otherwise intuitively also I could have directly written down this expression. But better to do the derivation, and we have done the derivation and we have find out these expression. But which derivation we ignored? We ignored the derivation to get these expressions. We ignored the derivation to get these expressions, right? How did I get minus gamma g upon h square? That derivation we ignored, and I can write it on paper 100%. They will never ask question on that particular derivation. Is that clear to you? Okay, because the mathematics involved there is something that you cannot understand. Even I cannot understand, to be very honest. Like all the steps you cannot understand. Like somewhere you need to make the assumption that okay, this is the answer of this particular differential equation. So why should we go into that complexity? So that's why I ignored that particular derivation. Okay, so we have got the expression of hzs. Now what we need to find? hx, hy, ex and ey. And what which equations we will use? These equations we will use. These equations we have already written down. How do we write it down? That also we have seen. So using these equations, what we can find out? Ex, ey, hx and hy. What we need to do? We just need to do the differentiations. So we will do the differentiation, and these expressions we will get. And which whose differentiation we will do? We will do the differentiation of hzs. And what is your hzs? Build the practice of writing it down. H naught cos m pi by a into x cos n pi by b into y e to the power minus gamma g z. So this is your HZS. And when you do the differentiations, these expressions you get for Ex, Ey, Hx and Hy. In the TM mode, what we have studied? TM mode. In TM mode, this was function of what? Cos x sin y. Is it same here? Yes, cos x sin y. So that is something good for you, that you do not need to remember for different things. Here it is function of cos x sin y. So certainly Ex is function of cos x sin y. So certainly Hy is also a function of cos x sin y. Here this is a function of sin x cos y, and this is a function of sin x cos y. So if you just remember this thing, then all the things will come to you on its own. Ex, Hy, Ey, Hx. Ex is cos x sin y, so Ey is sin x cos y. Okay, let's see the existing, non-existing and lowest order mode in TE mode. Okay, so what will be the subscript? Again, subscript will be mn. So I need to see which values of m and n I can put. Okay, what is m? Number of half cycle in x direction, and what is n? Number of half cycle in y direction. Same thing is there. Here, since this is transverse electric, that means EZS is already 0. But let's talk about other things. So if I put m is equals to n equals to 0. So if I put m equals to 0 here, if I put n equals to 0 here, this is gone. If I put m equals to 0 here, this is gone. If I put m equals to 0 here, this is gone. If I put n equals to 0 here, this is gone. Now what do I get? HZS will be a constant value, because if I put m equals to 0 here, HZS will be H0. If I put n equals to 0 here, this will be 1. N equals to 0, if I put this will be 1, and this will also be 1. So HZS, what you will get? HZS will be H0 e to the power minus gamma g z. Okay, this you will get, and rest all things will be 0. What all things I am talking about? EXS. All these will be 0, because if you put m equals to 0 and n equals to 0, if you put n equals to 0 here, this is 0. M equals to 0 here, this is 0. M equals to 0 here, this is 0. N equals to 0 here, this is 0. So all these are 0. HYS, all these are 0. Now you let me know one thing, whether this mode will be existing or not. What do you understand by this equation? What do you understand by this equation? That H0 is some magnitude. It is having standing wave in x direction, standing wave in y direction, and traveling wave in z direction. And this is how our EM wave propagates inside a waveguide. This is what I told you. Standing wave in x, standing wave in y, and that will be propagating towards z. It can never happen that a constant magnitude is traveling towards z. No standing wave. In x direction, in y direction, there is no electric field, there is no magnetic field, there is no standing wave, there is nothing, and only a constant magnitude is traveling inside the waveguide. That is not possible. So this mode is not possible. Why is that so? Because there is no standing wave. What I am writing down here, from here what I am writing down, if there is no standing wave, then there is no chance that any EM wave will propagate inside the waveguide. If wave is propagating inside the waveguide, certainly there has to be standing waves. So if there is no standing wave, that means this is non-existing mode. Say yes or no. Now let's see the next one. Here also EZS is already 0. But let's talk about these things. M is equals to 0, N is equals to 0. If I put M equals to 0, but N is non-zero. N is some finite value. N is non-zero. So certainly there will be standing wave. There will be standing wave in y direction. There is no standing wave in x direction. It is okay. But certainly there is standing wave in y direction, because what this is representing? Standing wave in y direction. Standing wave in x direction is gone, because m equals to 0. If I put m equals to 0, that means this standing wave is gone. So what will be the HZS expression you will be getting? HZS will be equals to H0, cos term will be gone. X term will be gone, and then y term will be there, e to the power minus gamma g z. So this is your HZS. So certainly there is standing wave. So HZS has no issue. So if there is standing wave, then certainly your wave can propagate in Z direction. So just by looking at this expression, you can say that this is existing mode. You do not need to care about EX, HX, EY, HY. But let's see what do we get. Let's see what do we get for M equals to 0 and N equals to non-zero. So if you put M equals to 0 and N equals to non-zero, so EXX would be existing. EXS would be existing. If you put what I am putting, M equals to 0. So if you put M equals to 0, this is gone. If you put M equals to 0, this is gone. But HYS will also be existing. If EX is there, certainly HY will also be there. Because both are brothers, no? You can put M equals to 0 here. If you put M equals to 0 here, then this is gone. If you put M equals to 0 here, then this is gone. But certainly, this thing is there. This thing is there. So this is not equals to 0. So here, HYS is not also equals to 0. Rest all are 0 only. This is also not equals to 0. This is also not equals to 0. I guess I will have to take it downward. I will have to take it here. So EXS, HYS is non-zero and rest two are 0, which is EYS and HXS. Both are 0. But from here only you can get to know that if there is standing wave, then certainly it is existing mode. So in case of TM, you can have 0 N, right? What this would be? This would be your TE 0 0. In case of TE, what this would be? 0 N. And what this would be? This would be TE M0. This is existing mode. Here EZS is already 0. What about HZS? N is 0. If N is 0, then this is gone, this will be 1, but this will be still there. That means standing wave is there. In X direction, standing wave is there. Standing wave in Y. Here, standing wave will be there in X. Certainly, there will be standing wave in X. And similarly, here your EYS will be non-zero and HXS will be non-zero. Since I have been studying it for a longer time, so I remember, but you can see it here. If you put N equals to 0, then this is gone. If you put N equals to 0, then this is gone. But if you put N equals to 0, then only this term will be gone. If M is finite, then this will be remaining. So EYS and HYS is non-zero, but EXS and HYS, they will be equals to 0. But since there is standing wave, certainly it is existing mode. And here in this one, there is no doubt. What is this? TEMN. So there is no doubt this will be existing mode only. Why is that so? Because here everything will be existing. HZ, EX, EY, HX, HY, and in HZ both kind of standing wave would be there. In X direction as well, in Y direction as well. So certainly this is existing mode. Okay. So this is your existing mode. So what is your non-existing mode in TEMN? What is the non-existing mode? Only TE00 is non-existing. This is also existing, this is also existing. Only TE00 is non-existing. Rest all is fine for our our TE mode. In TM, how will you remember? That in TM you can never put it equals to 0. So one of them can never be 0. One of them can never be 0. Or two of them can never be 0. But in TE, only TE00 is not there, rest all are there. Okay. And what could be your lowest order mode? Why I have left so much space here? What could be your lowest order mode? So it could be either TE10 or TE01. That what could be the minimum value? M value is 0, N value is 1, or M value is 1 or N value is 0. No one will ask you this in examination. I have just written it. So TE10 or TE01 could be there. Okay, right? Now possible modes. If I need to tell the possible modes. So now let's tell the possible modes. TE12 possible, TE02 yes possible, right? Because in subscript E you can have 0. TE10 possible, TE21 possible, TM20 team cannot be put to 0, so this is not possible. TM11 possible, TM12 possible, TM00 not possible, TE00 not possible. That's it. Okay. So did you understand this question? These kind of questions are asked actually in GATE examination, because they ask very easy question from waveguide. So if they ask these kind of questions can also come. Okay. So very simple thing, TE00 is non-existing, rest all are existing. So if I write down existing mode, no need to write down existing, because apart from this everything will be existing, so that's fine. Okay, let's see the summary now. So rectangular waveguide doesn't support TEM mode, it can support TM mode. In TM mode what will happen, transverse magnetic, that means HZS is equals to 0 and EZS is equals to non-zero. So if EZS is equals to non-zero, then what will be the expression you will be getting? ECE is sweet, so E sin E naught sin m pi by a into x sin n pi by b into y e to the power minus gamma z. What does this represent? Very important. Standing wave in x. What does this represent? Standing wave in y. And what does this represent? Traveling wave in z. Now EXS, what that would be a function of? So if you forget it, then what you are gonna do? You are just gonna think, okay, TM mode. What you are gonna think? Sir, TM mode. So in TM mode, minus gamma g upon h square, del by del x, EZS would be existing. Okay, and EZS is having function sin. So if I am differentiating with respect to x, then what I will be getting? This will be cos x and this will be sin y. Then I will be remembering that they are brothers. So this will be a function of cos x and since it will be a different function because amplitude will be different, so I am writing g here. Cos x and y. What about hsx? So E, F, G, H, any other function it is. F1 function, G1 function. This is some different function. But HXS and EYS are brother. So if EX is a function of cos x sin y, then this is a function of sin x cos y. And these two are brothers. So here I can write down this as G2. So this will be a function of sin x cos y. Just the opposite we need to do, cos x sin y, sin x cos y. So if you remember these things, then it will be very easy for you. And in TM mode, what are the non-existing mode? TM00, you can never put your TM equals to 0. So 0 n is also non-existing and TM M0 is also non-existing. Okay. If you remember these things, then mostly problem you will be able to solve. Along with that, you can remember that formula as well. In the last lecture, which conclusion we wrote? The conclusion of last lecture. This was the conclusion of last lecture. So this also you can remember. So till now in the discussion of roughly around 2.5 hours, it is 2.5 hour discussion. In this 2.5 hour discussion, that one slide is important and now this slide is important. So if you remember these conclusions, then most of the problems you will be able to solve. All the PYQs certainly you will be able to solve, but upcoming problem also you will be able to solve very easily. I just feel that someday they can ask some question from boundary condition. That's why I told the boundary condition. Rest all things you already know, that how the sign is coming, all these things is clear to you. And once you remember only this thing, that EXS is a function of cos x sin y, then it is cakewalk for you. Otherwise you can derive in the examination as well, that it is a function of cos x sin y only. We will see the questions that why we are spending so much time here. Okay, we will certainly see the questions that why we are spending so much time. Non-existing modes are TM 0, 0, 0 n and M0. What about TE mode? So this was the expression. What is this? This is standing wave in x. What does it represent? Maxima of magnetic field. Magnetic maxima at x equals to 0 and x equals to a, and magnetic maxima at y equals to 0 and y equals to a. And what does this represent? Traveling wave in z. What will be EXS? That will be a function of cos x sin y. Even if you forget, you can derive in the examination. And both are brothers. So this will also be a function of cos x sin y. If I just need to take the opposite, so this will be a function of sin x cos y, and this will be a function of sin x cos y. And what was the non-existing mode? TE 0, 0. Okay. Now where these things will be used? Let's see the questions. Now you need to tell me the mode. Looking at these expressions, you need to tell me the mode. Try writing it on your own. If you are not able to solve, then see the solution. Certainly see the solution. Even if you are able to solve, then also see the solution. So 1, 2, 3, 4, 5, 6 and 7 expressions are there. You need to tell the modes of them. Okay. So try writing it on your own. I will take a break and then we will start the solution. Okay. Okay. So let's start now. So first expression. So here there is no ax, ay, az. So you cannot tell whether it is your hzs component, hxs component or hys component. Basically your electric field will be, sorry, your magnetic field will be hxs ax cap plus hys ay cap plus hzs az cap. And in the similar manner, your electric field will be exs ax cap plus eys ay cap and ezs az cap, and all three components will be non-zero. Now here if I had written az cap, then you would get to know that it is hz only, but I did not write az cap here. Still I can tell that it is hzs only. Why is that so? Because what I can see, cos cos, and if it is a function of cos cos, if it is a function of cos cos, otherwise this is a function of cos cos. All these are cos sin, sin cos, sin cos, cos sin. This is a function of sin sin. These are cos sin, sin cos, sin cos, cos sin. So if it is cos cos, what does that mean? It is a function of cos x, cos y. Then certainly it has to be hzs only. This is written hzs only. Why is that so? Because only hzs is a function of cos cos. And how will you remember? Himanshu is careless, so cos cos. Hzs is a function of cos cos. So if hzs is existing, then which mode it has to be? Transverse electric, right? Because if hzs is there, that means ezs will not be there. Both simultaneously cannot be there, right? It can be there, but we do not need to study it. hzs and ezs can simultaneously there, but we are not studying it. In our waveguide, in rectangular waveguide, ezs and hzs simultaneously cannot be there. So if hzs is there, certainly ezs is not there. That means electric field is transverse. So transverse electric. Now I need to write down mn. So x is always associated with m and y is always associated with n. So value of m is 2 and value of n is 3. Right? Cos m pi by a into x, cos n pi by b into y. So TE23 mode it is. This is your answer. Now here sin sin is given. So undoubtedly I can tell that it is Ez. Undoubtedly, because this is a function of sin sin. So undoubtedly I can tell that it is EZs. And if it is EZs, that means HZs is not existing, that means this is transverse magnetic. And mode if I need to tell, so m pi by a, so m value is 3 and n pi by b, n value is 1. So TM31 is the answer. What about this guy? Here AX cap is given. AX cap is already given. So certainly you can tell that it is your HXS. Now HXS can be a function of sin x cos y. Do you agree to this point? HXS is always a function of sin x cos y. Do you agree? In both, in transverse electric as well, in transverse magnetic as well. Here what you can see? Here you can see sin. That means basically psi HX is a function of sin x cos y. HXS is a function of sin x cos y. Same goes for transverse magnetic as well. So you cannot conclude whether it is transverse electric or transverse magnetic. Now let's write down the Mn value. What we are going to write down? We are going to write down the Mn values. Mn value. I need to write down Mn values. So let's write down the Mn values now. So here sine 3 pi by a into x is given. Other term would have been cos, right? So cos n pi by b into y would have been there. But cos term is not there. That means cos term is 1. This term is 1. And when this term can be 1? When n is equals to 0. Because if n is 0, then cos 0 is 1. So n has to be 0. From here, when I saw this expression, I go to know that it is hxs. And hxs is a function of sin x cos y. Because what do I remember? Exs is a function of cos x sin y. Then ex and hy are brothers. So hx will be a function of sin x cos y. But now I cannot conclude whether it is TE or TM, because in both of them, in TE as well and in TM as well, hx is a function of sin x cos y. So I cannot conclude. So I wrote down that both are possible as of now. But now I am writing down the Mn value. What I get to know, my M value is 3. But n value has to be 0, because here there was cos, so n value has to be 0. So cos 0 would be 1. So n value has to be 0. And here Tm 30. So this answer we are getting. But tell me one thing, is this possible? Tm 30. Tm can never be put to 0. So this is not possible. So this is the answer. That's it. Did you understand what did we do here? We saw this is hx. And I know that my hx is a function of sin x cos y. So sin x cos y. But it could be TE mode as well and TM mode as well. Then I saw that what is my Mn value? M value is 3, N value is 0. So TE 30, TM 30. These are my two answers. But then I go to know that transverse magnetic cannot afford having 0. So this is not even possible. So this is the correct answer. That's it. Same goes for this one. What is this? This is your Ex. And do you remember Ex is a function of cos x sin y. Ex is a function of cos x sin y. What they have given? Sin x cos y. Is that possible? So this expression is not even possible. Not possible. Why it is not possible? Because whether it is TE mode or it is TM mode, Ex will certainly be a function of cos x sin y. Ex will certainly be a function of cos x sin y. But here what they are saying, that your Ex is a function of sin x cos y. Is that possible? No, not possible. So this expression itself is wrong. So it is neither TM mode, neither TE mode, it is no mode. This expression is not even possible. In rectangular waveguide, you will never get this expression of electric field. So these kind of questions are very, very important. Okay. From this discussion, these kind of questions can be framed. And I can tell you, like 99% of the students will not be able to understand these kind of problems. They will feel that derivation is required. Here derivation is not required. Here your brain is required. And the points that I have told, those are required. The summary that I have written, those are required. Right? Let's go here. What is this? Here I can see AY is given. So certainly it is your HYS. And Ex and Hy are brother sister. So it is cos x sin y. So it is a function of cos x sin y. But it is there for both TE mode and now I will check cos x sin y. Yes. So it is possible now. So this is there for TE mode as well and TM mode as well. But now I will check the value of Mn. So here I can see the M value is 5 and N value is 3. And here I can see that M value is 5 and N value is 3. How I can say? X is always associated with M and Y is always associated with N. So 5, 3. So here both answers are possible. So this kind of expression you can get in TE mode as well and TM mode as well. And the base value will be 5, 3. So here both answers are possible. So if it is an MSQ, you will click on both of them. But if this was an MSQ, then you wouldn't click on TM30. You would only click on this one. And if this was an MSQ, then you would say that it is not even possible. Are you getting this point? Okay. Yeah, so now we will see the F option, but there is a change in the problem. Okay. What is the change? Here instead of omega mu, I have written omega epsilon. And instead of sine cos, I have done cos sine. So problem I have changed. Previously it was something else, now I have changed because previous question would not make any sense. So that's why I have eradicated it. Now I have made this cosine. So this is the problem now. Now you need to tell the mode of this one. So I have made a change because there was an error from my side while framing the question. So now I have framed it correctly. Okay. So how will I do it now? So what I can see, this is your HYS, and HYS is a function of EX and HY are brothers. So HYS is a function of cos x sin y. Is it given? Cos x sin y? Yes. But this is there for both TE and TM. This is there for both TE and TM. Now I can write down the Mn value 2, 3. M value is 2 and N value is 3. So here also 2, 3. Both are acceptable. Both are the correct answer. What do you think? Both are acceptable. Think about it. Here both were acceptable, right? Same analysis we did here. Exactly same analysis. HYS is there, cos x sin y. 5, 3. 5, 3. Here this was the magnitude. Here what is the magnitude? Look at this. Omega epsilon upon h square. So if I write down HYS expression, how do you write down HYS expression? Sir, minus gamma g upon h square, then del by del y, sir. Then here HZS would come, since this is HZS would come. Then sir, j omega epsilon upon h square. Then del by del x EZS would come. Sir, about plus minus. So Himanshu's x was positive, so this would be negative. So this is the expression of sir HYS, and this is given in front of you. Now one of EZ or HZ would be existing. You don't know which is existing, but certainly one of either EZ would exist or HZ would exist. Both simultaneously cannot be existing. If I say that HZS is non-zero, then in the beginning of my expression, I would be getting minus gamma g upon h square. Basically, gamma g upon h square I would be getting if HZS was non-zero. If I say my EZS is non-zero, then in the beginning of the expression, what I am getting? Omega epsilon upon h square. So what you will notice that here omega epsilon upon h square is coming. That means certainly EZS would be existing. Now you do not get confused with this H naught. H naught can be amplitude of EZS as well. That I am writing down the amplitude of EZS as H naught. I did not say that H naught is the amplitude of HZS. Not necessary. People will think that sir H naught is there, so HZS would be the answer. That HZS is existing. If HZS is existing, that means electric field is transverse, then TE mode. This is the answer. People will click on this just by looking at this H naught. But this H naught is a trap here. H naught is a constant value, no? It can be a magnitude of EZS as well. But the thing is, if EZS is existing, then only you can have omega epsilon upon h square. Here you are having omega epsilon upon h square. That means EZS exists. Are you getting this point? So let me write it down here. What I can see is that omega epsilon upon h square, and here this is EZS. So both can be related. So that means EZS is non-zero. Certainly then HZS would be 0. So what is this? Transverse magnetic. So this is the correct answer of this one. Good question, but there is less chance that they would ask these kind of problems. They can ask these kind of problems. Very good question. They can ask these kind of problems. Very good question. Here both are the possible. Here it feels like that both are possible, but only one is possible. But here you need to write down these expressions. So very rare chance, but if they ask, then it would be very good for you. Are you getting this point? If they ask it, then it would be very good for you. You need to see this thing. In the magnitude, you need to see that omega epsilon upon h square you will only get if EZS is non-zero. So that means magnetic field is transverse. So TM23 is the correct one. And here you cannot conclude whether magnetic field is transferred or electric field is transferred. So for both of them you can get this expression. Basically here in this question, this 6 is written. So 6 is equivalent to this much of magnitude. They wrote this magnitude as 6. So if I had written a constant value here, then I was not able to conclude. But here I have seen omega epsilon upon h square. So whenever you see omega epsilon, you would know that certainly EZS is existing. And whenever I see omega mu, I will certainly see that HZS is existing. Are you getting this point? Because omega mu, if you remember the expression, j omega mu upon h square, del by del something here, HZS would come. So if I see omega mu, then HZS is existing. And if I see omega epsilon, that means EZS is existing. Are you getting this point? So a very good thing. So this is the so this is the best level they can go. Let's see this one. This is easy only. So Yeah. Is this possible? Is this possible? Because what do I know is that my EZS is a function of sin x, sin y. What else I know? My EXS is a function of cos x, sin y. And my EYS is a function of sin x, cos y. This is only for transverse magnetic mode, but this is there for both of the modes. This is there for TE, TM, both of the modes. But in any mode, anywhere, it can never be function of cos x, cos y. It can never be a function of cos x, cos y. So what does that mean? Not possible. So all kind of patterns we have seen, and certainly if the question is asked on this particular pattern, then you will be able to solve. So this is the end of our lecture. I hope you enjoyed it, and you must have understood a lot of new things if you have already studied from anywhere, because here we have seen a lot of new things. So this is the summary. If you keep these things in mind, then it is okay for you, and the summary of last lecture also you need to keep in mind. So these two combined would be more than enough for you. Okay, then thank you very much. In the next lecture, what we are going to start, we are going to see the waveguide parameters. So we are going to develop a lot of formula, and with the help of those formula we are going to solve the problem. So in the next lecture we will see waveguide parameters. Along with that we will see power flow. Along with that we will see the field patterns. So these three topics we are going to see. Okay, thank you.